In lesson 8.1, we're going to learn about something called standardized scores. The context for this situation is fantasy sports leagues. You may be already familiar with fantasy football, fantasy basketball, and so on. But fantasy sports leagues of all different types have become really popular in the last 30 years. And you can be involved in fantasy sports leagues for baseball, football, NASCAR, and even for fishing. In fantasy sports leagues, participants draft teams of actual players and then use their real life statistics to measure the performance of their fantasy team. Each fantasy team is then ranked according to different variables. And one example of that would be like batting average for hitters, strikeouts for pitchers, and so on. The fantasy team with the best average ranking is the winner. So obviously, you want to try to have good players on your fantasy team, but deciding who to draft can be difficult because when you are comparing pitchers to hitters, you're looking at performances that are on very different scales. And as one example, we're going to look at a couple of players from 2009. Ichiro Suzuki of the Seattle Mariners had a batting average of 352, which we know is really good. But Adam Dunn of the Washington Nationals hit 38 home runs. Now, both of these are really good performances, but we want to know which one was better compared to other players in that same category. It's difficult to compare a batting average to number of home runs because they're measured on different scales. So we have to come up with a way to compare things that are measured on different scales. And so to do this, what we do is we standardize these performances. So first, we're going to look at dot plots showing batting averages for all the players in the MLB for that year and also home runs. And so on the slides here, you can see that there are red dots on each graph. So the red dot on the left represents Ichiro, and the red dot on the right represents Adam Dunn. So we know that the batting average, or the average batting average rather, for that year for all players is 0.270. So on the graph, 0.270 is right where that red arrow is. And notice that Ichiro is above the average batting average. So we want to know how much above that he is. So we can subtract, and that tells us that he's 0.082 above the average for the league that year. Now, on the other graph, for the average number of home runs for that year, it was 15.3. And 15.3 is right where that arrow is right there. So you can see that Dunn is also quite a bit above the average. So we want to know how far above the average he is. So if we do 38, which was his number of home runs, minus the average, 15.3, we can find out that he is 22.7 home runs above the average. So this is a little bit more useful to us because we know how far above the average each player is, but it's still difficult because they're measured on different scales. So does it make sense to say that Dunn outperformed Ichiro based on these deviations just because 22.7 is more than 0.082? Not really, because they're still measured on different scales. So what we want to do then is to figure out not only how many points or how many home runs they are above the mean, but we want to know how many standard deviations they are above the mean, because the standard deviation describes how spread out the data is. So that would be like a more consistent way to compare their performances. So, for example, in 2009, for the distribution of batting averages, the mean was 0.270 and the standard deviation was 0.029. So if we subtract Ichiro's batting average, subtract the mean from it, and we divide that by the standard deviation of 0.029, that tells us that he is 2.82 standard deviations above the mean. For the other player, we can do the same thing with a number of home runs. So he hit 38 home runs. We subtract the mean from that. That tells us how far above the mean he is. And then we divide it by the standard deviation of the home runs, which is 9.9. And that tells us that he is 2.29 standard deviations above the mean. So now essentially what we've done is we've canceled out the units and we're measuring them and comparing them by standard deviations, which is the same unit for each. So 2.82 is bigger than 2.29. Now we have a meaningful way to compare those two players. So what we've done here is we've created what's called a standardized or a score or a z-score. And what this does is it measures how many standard deviations a performance is above or below the mean. The formula for a z-score looks like this. Z equals the performance for the player minus the mean for all the players in that category divided by the standard deviation. If a player has a positive z-score, that means that their performance is above the mean. If they have a negative z-score, that means their performance is below the mean. And when a z-score is 0, that means their performance is at the mean exactly. Let's look at another example. In the 2008 NFL regular season, quarterback Kurt Warner of the Arizona Cardinals had an average of 286 passing yards with a standard deviation of 103 yards. Let's calculate a z-score for a game in which he threw for 389 yards. Now, 389 yards is above his average, so we should get a positive z-score. Here's the calculation. So we do his performance of 389 minus the mean of 286 divided by the standard deviation of 103. And that gives us a z-score of exactly 1. So what does that tell us? This performance was 1 standard deviation above the mean performance. If the z-score for a particular game was -2, how many yards did he throw for? Well, -2 means that that performance was 2 standard deviations below the mean. The calculation that we would use to find that is we would take the mean, 286, and subtract 2 standard deviations from it. So 2 times the standard deviation of 103. And that would tell us that he had a game where he only threw for 80 yards. Part D says, if the z-score for a particular game was 0, how many yards did he throw for? Well, 0 for a z-score means he was at the mean, and the mean in this case is 286 yards. If the z-score for a particular game was 1.87, how many yards did he throw for? So 1.87 means that he was 1.87 standard deviations above the mean. So again, the way that we can calculate that is to take the mean and add 1.87 standard deviations to that. So 286 plus 1.87 times the standard deviation of 103 gives us a game of 478.61 yards. Now let's talk briefly about what z-scores are considered to be unusual. We're going to use Kurt Warner again. And this time you're given his average for the season, you're given the standard deviation. And we want to know, based on this information, what would be considered an unusual performance for Kurt Warner? We have the average number of yards that he passed in each game. They're ordered for you from smallest to largest, and we also have a dot plot. So it looks like he was fairly consistent, but he did have one game which seemed to be really bad. He only threw for 30 yards, and his best performance was 472. So question A is asking, how many of these games were within 1 standard deviation of the mean? Well, 1 standard deviation within the mean means start at the mean and go down 1 standard deviation and go up by 1. So down 1 standard deviation would be 183 yards. If we go up 1 standard deviation, that's 389 yards. So how many of his games were between 183 and 389 yards? Well, if we look at the games in order, all of those games that are in that red box are in that range. And that's 13 out of the 16 games, which is almost all the games. Now let's do the same thing for within 2 standard deviations. Within 2 means 2 below the mean up to 2 above. So 2 standard deviations below the mean would bring us down to 80 yards. 2 standard deviations above the mean would bring us up to 492. And if we look at all of his games, that is all of his games except for 1 were within that range between 80 and 492. So that's 15 out of the 16 games. Now, if we go out 1 more standard deviation from there, we look at 3 standard deviations. 3 standard deviations below the mean would put us at -23 yards. 3 standard deviations above the mean put us at 595 yards. And notice that 100% of his games fall within this range. So typically in statistics, anything within 3 standard deviations is considered to be kind of like a typical or a normal performance, and anything outside of that is considered to be unusual. So if Kurt Warner were to throw for, let's say, 700 yards in a game, that would be considered an unusual performance. Is it possible that he could have a game that was more than 3 standard deviations above the mean? It is possible, but it's not likely. All right, thank you for watching this video. Have a great day.